Okay, this is lecture 2.2. It's on circles. So let's actually draw a circle. So if you think of a circle, we can just draw a point right here. And a circle, I'm going to try to draw it. I don't know if it's going to work or not with that point. Let me just try to draw a circle. I'm kind of limited on the tools I have. Let me erase that. And so there's my circle, and if we look, there's a special place on the circle, and it's called the center. It's a point, and if we draw a line starting at that point to the edge of the circle, then the distance, that's called the radius by the way, then the distance between that point and any other point on the circle, say I'm going to exaggerate here, here's one point right here, and here's one point right here. There's, of course, my center point. So the distance here, I'll call that distance 1, and distance 2 are always the same. So the circle can actually be defined as given a point, and we're going to label this point, it's called the center, we're going to label that point HK, because that's what the book says. So given a point in the Cartesian plane, if I take all of the points, notice I'm pointing to the edge of the circle, that are the same distance from that single point, then the set of all such points is a circle. So before Descartes in the Cartesian plane, we only had geometric concepts related to the circle. We didn't actually have algebraic ones. So let our point, our center point, P, be HK. So HK is just a point. I'm just going to call it P, and P is our center. So then that means the distance between every point that lies here, any point that lies on the circle, remember our distance formula, is from that point, given by, I'm going to give the general equation, x1 minus x2 squared plus y1 minus y2, not in the exponent, squared. There we go. So that's our general distance formula. But in this case, the distance is constant, and it's constant from a single point. That single point has the h value, the x value is h, and the y value is k. So any point xy, that's the reason I took the subscript off, any point xy from the point hk is going to be the same distance. So what am I going to do now? I'm going to call the distance squared is equal to h minus x minus h squared plus y minus k squared. So that distance right here is given a special name. It's called the radius. So I'm going to replace the d with a r just so it will stand for radius. And we have the following equation. R squared is equal to x minus h squared plus y minus k squared. So all of the points x, y, which make this equation true, remember h and k is a fixed known point, is the following. It is a circle centered at the point hk. And that indeed is the equation of the circle. X minus h squared plus y minus k squared is equal to r squared. So that describes, when you actually graph that, that will graph a circle of radius r at the center hk. So let's actually show that really fast. So I'm going to go over here to GeoGebra. And let's just say my center point is going to be, we'll go 4 and 5. Right there is the center point. So let's make our radius 2. So let's type in the equation. X minus, what is the k value? This is my center point. So x minus 4 squared plus y minus, and what's my coordinate for the center point y value? It's 5. And we're going to square it. And I said I wanted my radius to be equal to, sorry, I don't want it up there. I want my radius to be 4, and that's the same as 2 squared. And right there we go. I have a circle centered at my point of radius 2. So if I were to draw a line segment from here to some point, we'll actually see that we've gone from 5 down to 3. So the radius is 2, and of course 2 squared is 4. This is my radius squared. 2 squared is 4. So there's a visual example of it. So what we're going to do is easy stuff at this point. At the first part, just getting used to it. We want to find the center radius form. So this form, this equation right here, x minus h squared plus y minus k squared is equal to the radius squared. It's called the center radius form. So here I'm given the center and I'm given the radius. So we want to find the center radius form of the equation for each of the circles. So let's do that. So I'm given that h is equal to minus 3 and k is equal to 4. So this is x. Now here again is the thing. These minus signs are inherent. So when I bring my value of, sorry, that's confusing. I labeled my circle with the wrong variable, thinking ahead. This is my center point. How's that? That's better. So my value of h in k, well, h is equal to minus 3 and k is equal to 4. So I just come back over here and my radius given is 6. So I literally just plug in the values here. 6 squared, and I know the formula up here has the radius on the other side, on the right hand side of the equation, and I'm not even going to entertain that that's important, because if a is equal to b, then b is equal to a, and I can put them on either side. So 6 squared is equal to x minus h, and my h is minus 3, y minus k, what's my k value? It's 4. And we don't expand this. The only thing we simplify is the 6 squared. So that gives me 36 is equal to, we want to simplify this part right here. X minus a minus 3 is x plus 3. Y minus 4 squared. So we'll actually see that that's a circle of radius 6 centered at minus 3 and 4. If we were to plot it. We're going to plot some other things later on. I'll let you plot that if you want it. So let's look at the next one. So here, my center, let me see if I can label this right this time around. The center point is equal to 0 and 0. So those are the values of h and k. So h is equal to 0 and k is equal to 0. My radius r is equal to 3. So here I'm going to go ahead, for those of you who might be throwing a fit, x minus h squared plus y minus k squared is equal to r squared. So literally all I'm doing now is just plugging in values. X minus 0 squared plus y minus 0 squared is equal to 3 squared. All of this simplifies to x squared plus y squared is equal to 9. So if I were to draw a Cartesian plane, this would be a circle centered right at the origin, because remember this is the origin of radius 3. So remember, 9 is not the radius. The square root of 9 is equal to our radius. 9 is equal to our radius squared. And since we don't have any sense of what it means to have a negative radius, we just take the positive square root of each side to get 3 is equal to our radius. And that's exactly what we were given over here. So let's see what we do next. So far pretty good. This is a pretty simple section until we do the following. And the next is not hard either. So we want to graph each of the circles given in the previous examples. So these are our equations. I've already given them to you. So this is what I'm going to do. Where is my flame shot? I'm going to take a screenshot of this because I want you to graph it. I mean, I know that you're at home and you don't have to get out graph paper or anything like that, but let's just pretend for a moment that we were literally in a classroom and you had to graph this on the test and in the classroom on paper. And you may have to do that. For some of you who will be going on to higher levels of math, such as calculus, the calculus track, will have to do a lot of graphing. So here, as you recall, if we're given something like this, what we have to do is we have to find the center point. So how do we find the center point? Now, we've already done that, but let's just pretend that we were given these two graphs. So let's do A. Something that we can read. So we have x plus 3, sorry people, squared plus, that's what happens when you're on call 24/7. Because of a pandemic. So you get Teams messages from students all the time. So x plus 3 squared plus y minus 4 squared is equal to 36. So that's x minus h squared plus y minus k squared is equal to r squared. So r squared is equal to 36. So by taking the square root of both sides, I get r is equal to the square root of 36, so that's 6. So I know I'm going to have a radius of 6. And let's find the center point values. So minus h is equal to 3. And minus k is equal to minus 4. So that means, this is always the hard part right here, and I don't know why, that means h, I'm going to multiply both sides by a negative, that means h is equal to minus 3, And this means k is equal to 4. So the point HK is equal to minus 3 and 4. So now we have our center point. This is our center, and our job is to graph it. And I'm gonna tell you right now, I'm only gonna do this once. I am bad at this. So let's find the center minus 3, 4. Let's find that point. So I'm gonna go to my graph. I'm gonna make it bigger, even though. So minus 3 on the x-axis is, there's minus 1, minus 2, minus 3, and I'm going to go up 4. So right there is minus 3 and 4. So the radius is 3. So, no, sorry, the radius is 6, right? Is that what we decided? Not 3, but 6. Yeah, the radius is 6. So what I'm going to do is I'm going to go up 6. Here's my center, so I'm going to go up 6. 1, 2, 3, 4, 5, 6. I'm going to put a point right there. I'm going to go over 6. 1, 2, 3, 4, 5, 6, right there. I'm going to go down 6. 1, 2, 3, 4, 5, 6. And I'm going to go over 6. 1, 2, 3, 4, 5, 6. And that's a perfect square, right? But I want to draw a freaking circle. I guess if you could just twist your paper. So there, that's the best I can do, people. So that's my circle. That's the reason we have computer aids, right? I couldn't even do it. I'm not even sure how it would work using my one computer aid. Oh. Okay, I can do it using this computer aid, more or less. But this computer aid actually will draw ellipses rather than a circle. So let's use the computer aid, put it right there, and I want it to hit both of those. So more or less that's what it's going to look like. So that's better. Freehanding is impossible. And that's all we're really going to do for that example. So again, you just find the center and you draw the center point, and then you go out in the up direction, the number of units of the radius, the right direction, the number of units of the radius, the down direction, the number of units of the radius, the left direction, the number of units of a radius. You've got 4 points. They probably are going to look like a square tilted, and you got to draw a line through them. The nice thing about all of this is you won't have to do that because your exams are in my math lab, and they give you a plotting tool. So you've got a computer already that does it for you. So as it turns out, not all circles are in that nice center radius form. So this is a typo here I've not fixed. This should be called not the center radius form, but the general form of the equation of the circle. I'll actually fix that problem. I'll fix that typo as soon as this is over and upload it, so if you wanted to re-upload the PDF. But if you're actually printing out these PDFs, you can just mark through it on your own. I see it on my notes that I've got it marked out, but I never went and changed it. This is the general form, not the center radius form. And it's x squared plus y squared plus dx for some real number d plus ey for some real number e plus f is equal to 0. And it has a graph of a circle, or it's the graph of a single point, or it has a non-existent graph. So let's think about this. Let me actually go over to GeoGebra. Here is a circle, and here's the equation for my circle right here. This is equation 4, and it's x minus 4 squared plus y minus 5 squared, so h and k is 4 and 5, and it's equal to 2 squared, which is 4, so the radius is 2. So what would happen if I changed the radius to 0? As it turns out, the radius is 0, and the circle shrinks to a single point. If I put in here a negative radius, like minus 4, what am I going to get? It doesn't plot anything. It says it's undefined. The point B for equation 4 is undefined because negative distances do not exist in the Cartesian plane, and it's really difficult to think of how we would ever interpret a negative distance. But a distance of 0 is a point. So a point is a special type of a circle. Sometimes it's called a degenerate circle. A point is a circle with radius 0. And then, of course, the regular circles that you imagine in your mind are circles with non-zero radii. And an equation that has a negative radius doesn't have a graph in the Cartesian plane. So that's what I'm saying right here. So I'm not for sure. This is a general equation right here. We have real numbers D, E, and F. They're always going to be integers. They're not going to be anything difficult like square roots or anything like that, but they could be any real number. And I can just choose some D, and I can just choose some E, and I can just choose some F. And I may or may not get a circle that has a graph in the Cartesian plane. It may have a non-existent graph. We still say it's a circle, and I'm really not for sure if we have a name for circles which would clearly exist if we extended our graph to complex numbers, but that's a 4-dimensional graph in a 4-dimensional space we can't really imagine. So at any rate, all we care about is the ones that exist in the Cartesian plane, and those are either points, circle of radius 0, or radii that are positive. So let's do one of these problems. So what are we being asked to do? Show that x squared minus 6x plus y squared plus 10y plus 18 has a circle as its graph by finding its center point hk and radius r. So here's what we're given right here. And we want to turn it in to this form. Why am I wanting to turn it into this form? Well, let's go back and let's make sense of this. So I'm given the general form, the center radius form is x minus h squared plus y minus k squared is equal to r squared. So this is equivalent to the following. I'm going to subtract r from both sides. X minus h squared plus y minus k squared minus r squared is equal to 0. So that's the reason I state the following. We want this over here. Since it's set equal to 0, that's equivalent to x minus h squared plus y minus k squared minus r squared. So that's what I'm going to do. So how are we going to do it? We're going to complete the square. So let's go through that. So notice the mathematical reasoning that you put in. This is what I'm given, and this is my goal. And once I have it into this form, then I know that since the original is equal to 0, here, that this over here on the right-hand side in the nice almost center radius form is equal to 0 too. So all I have to do is move the minus r squared to the other side, and I have my center radius form. So for right now, all we're going to do is we're going to look at this. We're going to look at the original equation. That's what we're going to look at. So let's get some writing space. So what we're going to be doing is completing the square. So what we do is, just like in all things, I'm going to do this in several steps. We really don't have that many problems in this section, but each problem takes a while to complete. So if you remember, in completing the square, so I've just copied this equation here to the equation down here. So when we completed the square, we always took the constant term and we moved it to the other side. And I'm going to put some room between what's remaining. So we move the constant term to the other side. So now what I'm going to do is I'm going to complete the square of the x value terms and complete the square of the y value terms. And here's what I do. You can do it however you want. I make a little table. And that table is divided, it's just into x values and y values. So let's start over here. So this is x squared minus 6x. This is my b term. B is equal to minus 6x on the x side. Well, what is my b equal to on the y side? B is equal to 10y on the y side. So I want to find out what b halves is. B halves is equal to, B is equal just the coefficients there, So the b is just ax squared plus bx plus c. B is just the coefficient. Sorry about that, getting ahead of myself. So I want to find out what b halves is. So b halves is equal to minus 6 over 2, which is equal to minus 3. So b halves squared is equal to minus 3 squared, which is equal to 9. And that's one of the things for those of you who actually solved an equation by completing a square, and I imagine those who didn't just didn't read the question well, because you just pulled out the quadratic equation and solved it that way. You didn't get any points for it because the whole point was to show that you could complete the square. So read the problems carefully. So what do? I add b halves squared to both sides. If I don't add them to both sides, then I break the inequality. And over here, I'm going to erase this equal sign. It's still there. I'm going to be using, that's my equals right there. I want a little bitty slot to put something in right there. So let's go over here and find what my b halves is. B halves is 10 divided by 2, which is 5. So that's b halves squared is equal to 5 squared, which is equal to 25. So I'm going to add 25. Maybe I can get away with doing it that way, to both sides. So what's the result? This is now a perfect square. X, and what is the value I put here? I put the value of b halves, minus 3. This is also a perfect square. And what do I put here next to the y? The value of b half, which is 5. And now all I have to do is add minus 18 plus 9, well, that's minus 9, plus 25 is 16. And I'm almost there because I want it in the form x minus h squared plus y minus k squared is equal to r squared. So I take this 16 is equal to my r squared. So the square root of 16, which is 4, is equal to my r. So my final answer is x minus 3 squared plus y plus 5 squared is equal to 4 squared. So the conclusion is this does have a graph. Does it have a graph? The answer is yes. And okay, what's the radius? The radius is 4. And what's the center? So what is the center? This is x minus h squared plus y minus k squared. Well, let's look. Minus h is equal to minus 3. Minus k is equal to 5. That means h is equal to 3. That's a minus there. K is equal to minus 5. So the center is 3 minus 5. So for some reason that little bitty move, given the actual equation that I came up with, so I guess here's another way to do it. If I have a negative here, just take that value. So this is my x-coordinates. Then take the actual value without the negative is my x value. If I have a plus there, then for my y value coordinate for the center point, take its negative. I think it's just so much easier just to not even worry about some rule like that, but rather look at it this way, and I'm going to do it one more time. We had x minus 3 squared, because this is pattern matching, plus y plus 5 squared is equal to 2 squared. And I want to pattern match that to x minus h squared plus y minus k squared is equal to r squared. So clearly h is equal to 3, but k, these two differ here, so k has to be equal to minus 5. Or just take the sign with it, like I did before, and say minus h is equal to minus 3. Sorry people, that's always, or minus k is equal to plus 5. And of course all you have to do in this case is you have to multiply by minus 1. That gives me h is equal to 3, k, that's supposed to be a 5 there, k is equal to minus 5. Okay. Sorry if that's really dim. I think you can see it fine though. So is that the same one? No, this is another one. Let's do another one. Another example of this. So I suggest now, if you want to really make the best of your time, when you're watching these lectures, pretend like you're in the classroom. And I actually imagine seeing you out there. Actually, now I know what some of you look like because, I knew what some of you looked like before because I had you as students, but now I know what some of the rest of you look like because I saw you in teams. Trust me, I'm not imagining any individual person. So let's do number 5. And what I'm going to challenge you to do is see if you can actually determine what the equation of this is. And then, of course, you're going to find the radius. And if the radius is negative, it's non-existent. If the radius is 0, it's a point. If the radius is positive, then it's a circle. It's just a standard circle. The point is sometimes called a degenerate circle. So I'm assuming you've paused this and you've actually got a solution. So let's start. So I'm just completely paralyzed if I'm given too many choices. Something I've noticed about myself as I've got older. We believe that choices make us free. In my case, they paralyze me. You ought to see me going through Netflix or Amazon. So the first thing I do is I take the constant term and I put it on the other side. And now I'm going to make the little graph for the values of x and y. So my b value for the x is 10. So my b halves is equal to 10 divided by 2, which is equal to 5. So that means b halves squared is equal to 5 squared, which is equal to 25. So I'm going to add a 25 here. And since I added it to one side, I have to add it to the other. Now let's repeat for the y side. So my b for the y side is equal to minus 4. That means my b halves is equal to minus 4 divided by 2, which is equal to minus 2. So that means my b halves squared is equal to minus 2 squared, which is equal to 4. So I'm going to add 4 to both sides. So let's go ahead and do a simplification. This is a perfect square. And the y can be expressed as a perfect square. And that's going to be equal to minus 33 plus 25 plus 4. That's minus 33 plus 29. So that's equal to minus 4. So presto, you already know, since the radius is negative, that this graph is non-existent. But we're still not done, because we still have to finish, we have to express it in the general form. So I got to find out what to put in here. So for here, I take the b halves value, which is plus 5. And for the y side, I take the b halves value, which is minus 2. So that's my general equation. X plus 5 squared plus y minus 2 squared is equal to minus 4. So minus 4 is equal to what r value squared? Well, I have to take the square root of 4 sides. So this is actually equal to r is equal to 2i. Now I want to stop you right now. I don't think that this step is required, but it already shows that the square root of minus 4 is I. Just a little bitty reminder. The square root of minus 4 is I times the square root of 4, which is I times 4, but we express that as 4 times I. So this is a pure imaginary number. It doesn't have a real part. Sorry, that's talking too much. Times 2, which is equal to 2 times I. There we go. So I don't think this part is required, but it's interesting And for those of you who do go on, and I hope some of you love math, and mathematics, I'll tell you, it's a beautiful field. If you're worried about getting bored before you get old, then when you get old, be a mathematician. There will always be plenty of problems for you to work on, unsolved problems in mathematics. Your laboratory is in your mind, in your textbooks, in your pieces of paper, and you always have something to do. So if you like patterns, solving puzzles, putting things together logically, then consider mathematics as a dual major or a minor. For the rest of you, you just want to get to this class so you can get done with your math and get your degree in another subject, which is fine. I'm just talking to those few of you who actually like this stuff. And in this case, you might want to wonder, what would the graph of that be like? And it has to deal with how do we graph complex valued functions? And that's a beautiful question in and of itself. And you won't even get to that until you were in a 4-year university and you took a class called complex variables. So here we have the most interesting little problem, an applied problem. So the epicenter of an earthquake is the region where slippage of tectonic plates occur, causing the earth to quake. If we treat this center as a point and ignore the curvature of the earth, we can find the origin of the earthquake by imposing a rectangular coordinate system on a geographic area. That means you're going to decide this is my origin, and you're going to lay out a grid. And it will be imaginary. You would actually do this if you were having Google Map. You'd be looking straight down, and you'd just overlay a grid over it. So suppose that the 3 earthquake recording stations are located at 1, 4, minus 3, minus 1. Let me write these down. So 1, 4, minus 3, minus 1, and 5, and 2. So let's actually do this. Let's go over to GeoGebra, and let's take out this point. I don't want us to see this point. So let's input the points 1 and 4. Let's do it by the point. Let's turn this off and off and off and off and off. So let's find the point 1 and 4. So there's my 1, so I go up to 4. There's 1 and 4. My next point was minus 3 minus 1, so there's minus 3. I go down to minus 1. And my next point was 5 and 2. So there's a 5, and there's my 2. So imagine that those are the locations of my 3 recording stations. So let's actually do something here. Let's draw circles centered at each. Notice here, these particular circles never, ever, ever intersect at a single point. So the radius of those circles, we couldn't use the radius of those circles. Maybe I shouldn't have drawn those circles. Let's go back and reread what we actually have to do, because what we're going to do is, I've got a point F there. Turn it off. Turn it off. Turn it off. Heck with it. Let's just regenerate a whole new palette. So let's go back over to our problem. So by using mathematics that calculate the timing of the earthquake waves through the earth, we find the distances from the epicenter to the earthquake recording stations are 2, 5, and 4 units of distance respectively. So 2, the radius, the distance, in this case is from the center to the edge, so that's the radius, is 2 and 5 and 4. So let's go back now and let's use GeoGebra. So again, let's locate these points, and I'm just going to do it the lazy way. 1 and 4, there's 1 point. The next point is -3, -1, and then my third point is 5 and 2. So there are my 3 points, just like I had before. So let's actually start right here with A, and let's draw a circle with radius 2. So I'm going to go down, and I'm going to stop when I get to 2 units below it. So that's going to be pretty close. Now for my point -3, -1, my point B, it has a circle of 5. So I'm going to, again, draw a circle, and I'm going to go 5 units to the right. There's 1 unit, 2 units, 3 units, 4 units, and 5 units. And for my circle C, it has radius 4. So I'm going to go over 1 unit, 2 units, 3 units, 4 units. So now we see the point D right here, all 3 circles intersect at a single point. And that point, it literally tells you, that point right here, and the point D is 1, 2. 1 is the X value, and 2 is the Y value. So that's what we're supposed to do, is we're supposed to actually graph and find the intersection. And the intersection of all 3 points is at let me write this down. All 3 circles intersect at the point, it was, what was that point again? 1 and 2. So what does that mean? That means all 3 circles, this point, 1, 2, so this means 1, 2, that's a point, lies on the graph of each circle. So I hope you understand there. So we identified the point graphically. I used GeoGebra. And the point where they all 3 intersect is 1, 2. We just grab that graphically. The next thing is we used our brain. That means this point lies on the graph of each circle. So tell me one more thing that I can infer from this. That means given, what this means is given the equation of each circle, if I plug in x equals 1, that's where I'm getting the 1 at, and y equals 2, that's where I'm getting the 2 at, I get a true equation. And our job is just to verify that this is actually the case. But before we do that, we have to get the equations for each of the circles. So we have circle 1. What is this equation? we're going to use the center radius form. Its center is given to us to be at 1 and 4. And its radius is given to be, radius squared is given to be 4. So we want to see and convert this to the general form x minus h squared plus y minus k squared is equal to 4. Well, h is equal to so how do I go from here? So this is 1, 4 is hk. So that's x minus 1 squared plus y minus 4 squared is equal to 4. So what do I want to know? I'm given the point 1, 2. Does it lie on this circle? So I plug in for x 1 and for y I plug in 2 and I ask myself, does it equal 4? Well, 1 minus 1 squared, 1 minus 1 is 0, 0 squared is 0, and 2 minus 4 is minus 2, and I'm squaring it. But minus 2 squared is equal to 4. So the first circle checks out. Let's do circle 2. Its center is minus 3, minus 1, and its radius squared, its radius is equal to 5, so its radius squared is equal to 25. So we have x minus h squared plus y minus k squared is equal to r squared, which is 25. This is the center, so hk, h is equal to minus 3, k is equal to minus 1. So this goes, remember that h has to bring its negative along with it. It can't use the one that's there. So x minus a minus 3 is x plus 3. And y minus a minus 1 is y plus 1. And that's squared, and that's equal to 25. And our test point that we want to test again is the exact same point, and that is 1, 2. So I'm going to plug in x is equal to 1 and y is equal to 2. And I want to see if it's equal to 25. So 1 plus 3 squared is 4 squared, and two plus 1 squared is 3 squared. And that's 16 plus 9, and that's equal to 25. So that checks out as well. And now all we have to do is the third circle. And we're given that its center is at 5, 2. So remember that's h and k. And the radius is equal to 4. So my radius squared is equal to 16. So x minus h, h is 5. Y minus k, k is 2, squared is equal to r squared, which is 16. And again, our test point is 1, 2. We're using the exact same point. So I put in 1 minus 5 squared. I'm testing this. 2 minus 2 squared. Is that equal to 6? What is that equal to? We want to see if it's equal to 16. Well, 1 minus 5 is equal to minus 4 squared. And 2 minus 2 is 0 squared, and that's equal to 0. So minus 4 squared is equal to 16, and that's what it was supposed to be. So we just verified that indeed the point 1 comma 2 is the correct point that lies on that lies on all 3 circles. So that's what we were asked to do, in case you didn't read. Check to see if the point we discovered graphically, we discovered that point from doing this graph right here. That's point D. D is 1 comma 2. I mean, we were supposed to sketch it on a graph paper, but you literally need a compass to get that. And we verified that that does indeed lie on all 3 circles. So all 3 circles intersect at that single point. So just one other thought question for you, and we'll be done. So here's some mathematical reasoning. In the implied problem about earthquake epicenters, we were able to check what the epicenter was visually. So in order to determine what it would be algebraically, we would need to solve the following 3 nonlinear equations for both x and y. And right there they are. You will not develop techniques in this class to solve it. I would actually have to review my linear algebra to learn how to solve all 3. I know exactly where to look. We did it before in quadratic forms, etc. But notice that's the reason they pretty much gave you the answer, and you just check to see if the point 1 comma 2, x is equal to 1, y is equal to 2, makes this first equation true, makes this second equation true, makes the third equation true, and indeed we did. So really the only thing I'm challenging you with is just to think how important this is. Now, can you think of a similar problem that might require a similar solution? And I give you a hint. In law enforcement, in areas where gunshots are common, in order to detect where the gunshots are coming from, recording microphones have been set up at different locations in the area to record the shots. And we know how the speed at which sound travels through the air, so we can explain informally how this setup might be used to find the location of the shots. And of course, we're grossly simplifying. We're not imagining someone running and shooting as he runs, that a person is shooting from a fixed point. But even if they're running and shooting, we can still get a kind of an area where they might be. And that's just one possible application of this problem. Can you think of others? So in summary, this was about circles. We really only had 3 things to do, really just 2. The general equation for a circle, how to convert it into the center point equation for the circle, and also determine, given a general equation for the circle, whether it actually describes an existing circle in the coordinate plane, or a degenerate circle, which is a point, or no circle at all that can be plotted in a 2-dimensional Cartesian coordinate system. And then we looked at one application.